Previously we had taken up limits in which part 1 was introductory based and part 2 में हमने कुछ results और उन results के based कुछ examples देखे थे. Now in this part we'll visit some properties, some results and उन results के based कुछ examples. As we know from the basic algebra of limits that limit of the sum of the two functions equals the sum of their respective limits, limit of the difference of the two functions equals the difference of their respective limits, limit of the product of the two functions equals the product of their respective limits, and limit of the quotient of the two functions equals the quotient of their respective limits. And eloping these properties, we are here to discuss some more general properties of limits. So our first property goes like this. If fx is a function such that its limit equals u, which is a positive number, then limit of the function fx to the power lambda equals limit of the function fx to the power lambda, which equals u to the power lambda. So obviously ये function fx to the power lambda, this can be written as fx into fx into fx into fx up to lambda times. So इसका अगर हम limiting value ले by the algebra of the product, we know it can be written as limit fx into limit fx into limit fx lambda times. Thus it can be written as limit fx to the power lambda. Since limit of the function fx equals u, so we can write this as u to the power lambda. Now second property will be if limit of the function fx equals u, then limit of a to the power fx equals a to the power limit of that function fx, which simply means कि limit power में चला जाएगा. Now again, if we have limit fx equals u, which is greater than 0, then limit of log of a function equals log of limit of that function. Since limit of fx equals u, so this will be log of u. This property is very important and very categorized property. So we say that limit of log of a function equals log of a limit of a function. Now कुछ important results देखते हैं. Number first, limit n tends to infinity 1 plus 1 over n to the power n, इसका limiting value e होगा, and limit n tends to 0 1 plus n to the power 1 over n, इसका limiting value भी e hoga. So where e is the transcendental number. Obviously these two limits seem to be somehow a bit confusing क्योंकि यहाँ पे limit n tends to infinity और यहाँ पे limit n tends to 0. Obviously we are computing limit at infinity and limit at a point. So यहाँ पे 1 plus 1 over n और यहाँ पे n, यहाँ पे n और यहाँ पे 1 by n, इन दोनों का ही limiting value e होगा. We do have a simple procedure to remember these two limits. We have to remember that we have to obtain 1 plus 0 to the power infinity, 1 plus 0 to the power infinity. And we have to use limits here in such a way that here we should obtain 0 and here we should obtain infinity. So यहाँ पे कौन सा limit फिर use करें? So it will be n tends to 0. अगर यहाँ पे n tends to 0, so obviously यहाँ पे n आएगा because n tends to 0, और यहाँ पे 1 divided by n, 1 divided by n, and if we are making the limit tend to infinity, so it will be limit n tends to infinity. यहाँ पे फिर n की जगह 1 by n, and here we will have n. These two limits are on the similar lines as of limit x tends to 0 sin x divided by x, which equals 1, and limit x tends to infinity sin x divided by x is equal to 0. And we know to prove this we have multiple procedures and multiple methods. One such is the consequence of the squeeze theorem and the famous L'Hopital rule for indeterminate form of the type 0 by 0 and infinity by infinity, in which we take the derivatives of the numerator and the derivatives of the denominator. And now our third result goes like this. Limit x tends to 0 log of 1 plus x over x, इसका limiting value 1 होगा. This limit can be obviously proved as the consequence of these and the previous property जो हमने अभी discuss की थी. So if we have to prove this, then we can write this will be limit x tends to 0. So we can write this as 1 by x into log of 1 plus x, so which will be limit x tends to 0, so log of 1 plus x to the power 1 by x. We know n log m equals log of m to the power n. As we previously discussed, limit of log of the function equals log of limit of that function. So it will be log of limit x tends to 0, 1 plus x to the power 1 over x to the power 1 over x. So which will be log of and this limit x tends to 0, 1 plus x to the power 1 over x, this equals e. So this is log e, and log e to the base e equals 1. Now the next property will be limit x tends to 0, a to the power x minus 1 divided by x. Iska limiting value log a, obviously a is the base here, and again limit x tends to 0, e to the power x minus 1 divided by x. Iska limiting value log of e, which obviously equals 1, because log e to the base e equals 1. In general, we have limit x tends to 0, e to the power fx minus 1 divided by fx. इसका लिमिटिंग वैल्यू 1 होगा तब अगर हम बेस e लें. अगर इसका बेस a लें, then in that case it will be log of base e, log of base e. एक एग्जांपल देखते हैं. लिमिट n tends to infinity 1 plus 1 over n to the power n plus 5. So we can write this as limit n tends to infinity 1 plus 1 over n to the power n into 1 plus 1 over n to the power 5. Obviously n plus 5, so this is n plus 5 basis का add करके. So it will be, since limit of product equals product of limits, so limit can be distributed. We can write limit n tends to infinity 1 plus 1 over n to the power n into limit n tends to infinity 1 plus 1 over n to the power 5. So this will be limit n tends to infinity 1 plus 1 over n to the power n into इसका limiting value अगर हम calculate करें, so it will be n tends to infinity यानी 1 plus 0 to the power 5, which is limit n tends to infinity 1 plus 1 over n into 1. By the previous result, this limit equals e, so this will be e into 1, so which will be equal to e. Now our second example is limit x tends to infinity 1 plus 2 over x to the power x. If we minutely observe this limit, then ऊपर numerator में 1, but here we have 2. That means we have to transform this limit in these terms. So we can do so by substituting 2 by x to some other variable. So if we write put 2 by x is equal to t, so that when x tends to infinity, t tends to 0. Thus we can write this limit as limit x tends to infinity 1 plus 2 over x to the power x, and this will be reduced to limit t tends to 0, 1 plus 2 by x. 2 by x is replaced by t to the power x. Value x का value 2 divided by t, which will be limit t tends to 0, 1 plus t to the power 1 over t into 1 plus t to the power 1 over t. So 1 plus t, it will be 2 by t. So again, limit of product equals product of the limit, so we can write this as 1 plus t to the power t into limit t tends to 0, 1 plus t to the power 1 over t. Thus we have this limit equaling e, so this will be e, this limit equaling e, so it will be e, so e into e, it will be e square. So the next example is limit x tends to infinity x plus 3 divided by x minus 1 to the power x plus 3. अब इस लिमिट में लाने के लिए we have to make sure कि पहली टर्म जो है that is 1, but here we have x. That means we'll be dividing numerator and denominator by x. So we can write dividing numerator and denominator by x. So it will be limit x tends to infinity, so it will be x divided by x, which will be 1 plus 3 divided by x divided by 1 minus 1 over x to the power x plus 3, which can be written as limit x tends to infinity 1 plus 3 over x to the power x plus 3 divided by limit x tends to infinity 1 minus 1 over x to the power x plus 3. As we already know, limit of the quotient equals the quotient of the limits. We can again write this as limit x tends to infinity 1 plus 3 divided by x into limit x tends to infinity 1 plus 3 over x to the power 3 divided by limit x tends to infinity 1 minus 1 over x to the power x into limit x 1 minus 1 over x to the power 3. So again, इस लिमिट में एग्जैक्ट लाने के लिए we have to substitute 3 by x and 1 by x. So we can write put 3 over x is equal to t and minus 1 over x to z. So when x tends to infinity, t tends to 0, and when x tends to infinity, z also tends to 0. Now 3 by x is equal to t implies 3 by t is equal to x, and minus 1 by x is equal to z implies minus 1 by z is equal to x. Thus we can write this limit as, this will be limit t tends to 0, limit t tends to 0, 1 plus 3 by x is t raised to power x का वैल्यू 3 by t into इसका लिमिटिंग वैल्यू 1 होगा divided by limit z tends to 0, 1 plus z raised to power minus 1 by z into इसका भी limiting value 1. So we can again write this as limit t tends to 0, 1 plus t raised to power 1 by t whole raised to power 3 divided by limit z tends to 0, 1 plus z raised to power 1 by z whole raised to power minus 1. And using the previous results in combination with the previous property, we can write this as e raised to power 3 divided by iska value e, then it will be e to the power minus 1. So it will be e to the power 3 into e to the power 1, which will be e to the power 4. So our next example is limit x tends to 0, log of a plus x minus log of a minus x divided by x. So we can write this as limit x tends to 0, log of, so इस टर्म में से a plus x में से हम a कॉमन निकालेंगे. So it will be a into 1 plus x divided by a minus log of, again a minus x में से a फिर से कॉमन निकालेंगे. So it will be a into 1 minus x divided by a whole divided by x, which will be limit x approaches to 0, log of a plus log of 1 plus x divided by a, since we know log of m into n equals log of m plus log of n minus log of a minus log of 1 minus x divided by a whole divided by x. So यहाँ माइनस क्योंकि यहाँ माइनस से मल्टीप्लाई होगा, which can be written as limit x tends to 0, so log a plus and log a is minus, so it will cancel out. So it will be log of 1 plus x divided by a minus log of 1 minus x divided by a whole divided by x, which equals limit x approaches to 0, log of 1 plus x divided by a whole divided by x minus limit x approaches to 0, log of 1 minus x divided by a divided by x. Now special limit में लाने के लिए we have to make sure limit x tends to 0, log of 1 plus x divided by x which is equal to 1. अब ये लिमिट यूज़ करने के लिए we have to check whether कि ये कंडीशन यहाँ पे सेटिस्फाई हो रही है या नहीं. सो इस लिमिट में पर्टिकुलरली लाने के लिए we have to make sure अगर यहाँ पे x by a है यहाँ भी then x by a होना चाहिए. एंड इफ़ यहाँ पे माइनस एक्स बाई ए है देन यहाँ भी माइनस एक्स बाई ए होना चाहिए. वी कैन मेक सो बाय राइटिंग लिमिट एक्स टेंड्स टू 0. सो इट विल बी 1 डिवाइडेड बाई ए लॉग ऑफ 1 प्लस एक्स डिवाइडेड बाई ए होल डिवाइडेड बाई एक्स डिवाइडेड बाई ए. 1 बाई ए से ये ए कट जाएगा. दैट मीन्स इट विल बी अगेन द previous term minus, so it will be limit x approaches to 0. यहाँ पे minus 1 by a लिखेंगे. then we'll write log of 1 plus minus x by a divided by minus x by a. again minus 1 by a से ये minus 1 by a कट जाएगा. So it will be 1 by a will be left out being constant and will be left out with limit x tends to 0 log of 1 plus x by a divided by x by a minus into minus it will be again plus 1 by a log of 1 plus minus x by a divided by minus x by a. This will be 1 by a into इसका limiting value 1 plus 1 by a इसका भी limiting value 1. So it will be 1 by a plus 1 by a which will be 2 divided by a.